Wasabi, you guys. Welcome to Integration Be Training for Advanced, and we are still in the Ninja Substitution part. So this is a part 3.2, and in this section, we're going to be learning how to use Ninja Substitution with logarithm functions. So let's go ahead and get into that. So we have this integral here. Just do some algebraic manipulation. That's all we just got to do. So we're just gonna, let me go ahead and just sort of reformat this. Right, 3 plus x, let's see, ln of 9 minus x squared. If you know your logarithm rules, that is just 3 minus x plus ln of 3 plus x. Okay, just by log rules. And now you can see, if we apply u equal negative x, it's just going to look like King's rule. It's going to look exactly like King's rule when we do u equals negative x. So of course, this is equal from negative 2 to 2, 3 minus x, ln 3 plus x plus ln 3 minus x. The denominator is still the same. And so when we add these two integrals together, we get, well, a half because of 2i. And then, of course, this plus this is the same thing as the denominator. And so it's just going to cancel out 1 dx. And so what we have here is this is pretty much just going to equal, let's see, 2 minus negative 2. That's 4 divided by 2. Our answer is just 2. Okay? What on earth is this? Secant of x minus tangent of x. What do we do here? Right? Well, notice that if we do u equal negative x, the only odd function is the tangent of x here. And so when we do this, we get ln of secant of x plus tangent of x dx. Oh, but wait, do you remember your intermediate training? Do you remember that secant of x minus tangent of x, well, let me rewrite this in orange. But yeah, secant of x minus tangent x, that might bother a lot of people. That actually hurts my eyes. But secant of x minus tangent of x is equal to 1 over secant of x plus tangent of x, and vice versa. So, and this is because, well, 1 plus tangent square, that we all know, is equal to secant square. And of course, 1 is equal to secant square minus tangent square. And because it's a squared minus b squared, we can factor this just like this. So that is why, if you remember from our secret secant section, this is pretty much negative ln of secant x minus tangent x. Aha! What do we say about I equals to negative I? That this integral is equal to 0. Alright, how do we solve this integral now? Interesting. Integration by parts. Let L derive ln 1 plus e to the x. Integrate x and then go from there? Of course not. We know better than that. Of course not. Let u equal negative x. Then we get negative x, and we have ln of 1 plus e to the negative x. Now you're probably thinking, okay, Silver, what does this even do? What does this even do? That negative, if you remember algebraic manipulation, that negative is going to reciprocate the inside of logarithm of ln of x. I'm sorry, of ln. And here, again, algebraic manipulation, -1 to 1, ln e to the x, e to the x plus 1. But now look, what happens if we add these two integrals together? Notice, by logarithm rule, when we add them together, the x, thankfully we have the x, so we can definitely put it together. We get ln of 1 plus e to the x times e to the x plus 1. This cancels out. We're left with e to the x. ln of e to the x is x, so what we have is x. This whole thing's x. We get x squared dx. So, of course, we have, by symmetry, just to solve this quickly, and we notice that this whole integral is equal to 1/3. Okay? Very cool. It's a little hard to see of what we were going, but now that you know, you have some experience. Okay? Of course, definitely try this integral on your own and see if you can remember the process, and then become comfortable with that. Now, to some of you, and when I say some of you, I'm talking about those G-main people. A lot of you guys might think, wow, Silver, a lot of these log integrals that you've been giving us, it's super easy, right? Well, I'm going to show you right now that this is not always easy, okay? This is one of them. This integral is one of them. This integral here is not an easy ninja substitution integral, okay? I'm going to show you why. If you dare to attempt this by yourself, good luck. I hope death doesn't upon you on this integral, but here, if we let u equal -x, the bounds stay the same, of course, and we're just going to be given x ln 1 plus, I'm sorry, -x. Negative sign of x. Okay. Now, of course, that negative is just going to reciprocate this, and then we'll end up like cosine of sine of x over 1 plus cosine of x to the power of sine of x. I'm just going to dive in. For the sake of this integral, because it's not pretty. I'm letting you know right now, this is not pretty at all. So we have 1 plus cosine of x sine of x. I don't know why I put it at the top like that. Times this, which is cosine of x sine of x. 1 plus cosine of x sine of x. Honestly, I wish I abbreviated this, but they cancel out, right? They cancel out, and you end up getting pi over 2, x over 2, ln of, let's see, cosine x to the power of sine of x, but by logarithm we could just take that out, right? Okay, and of course this is an even function. Awesome. 0 to pi over 2. We have x sine of x ln of cosine of x dx. Now what? Interesting. So this integral is the reason why I say this is not a pretty integral. Okay, it's not always easy. Ninja substitution is not always easy. Okay, I'm being real with you. This is not an easy integral. This integral, oh my god. We're gonna do integration by parts. Okay, because there's no other nice way to go around this. But I could be wrong though. Unless otherwise, just tell me in the comments what your shortcut is. But let u equal cosine of x. Of course, you know, you get ln of u ln of u minus u. So we have cosine of x, which is technically, I'll just factor it. Okay, so that's where it should come out. I'm sorry. Take this away, because x cosine of x, that's just 0. So what we actually have this when we simplify it. X cosine of x ln of secant of x. And then let u equal cosine of x. It's not substitution. It's not u substitution. This is all limits. This is just all limits. This is all limits affiliated. So then inverse cosine ln of 1 over u. This is exactly like this integral here, which everything becomes 0. It's so evil. It is so evil, the fact that this whole limit here is equal to 0. So evil. Now we can just focus on here. And then this is just cosine of x, right? Which is just minus 1. And then we have plus. Now we have to deal with this. Right? And now how do we compute this? How do you compute this? We have to do integration by parts again, unfortunately. Which is all right. It's okay, I guess. It's okay. It's okay. But for the sake of speed, it's just annoying. So I'm going to do it at the side. Ln of cosine of x. Cosine of x. And we get, let's see, negative tangent of, oh, I'm sorry, no, it gets positive. And then this is sine of x. So what we have is minus 1 plus sine of x ln of cosine of x from 0 to pi over 2. And then we have tangent times sine, which is technically from 0 to pi over 2 sine square cosine of x dx. That's what this equals. Okay? And so now, here if we plug in pi over 2, plug in pi over 2, we get 1. But then plug in cosine of pi over 2, that's 0. Oh no. Oh no, this limit diverges. However, the whole integral converges. So, which means that you have to wait on this integral. So, this is what I call limit blocking, which is the most evil way to write integrals for integration bees. So, let's go ahead. See, plug in 0. That's just 0. So, let's just go ahead, write this out. Pi over 2 sine of x ln of cosine of x. Okay? And we're just going to have to wait that out. Here, we go ahead and integrate it. When we integrate it, if you remember trig manipulation, this is 1 minus cosine square. You get secant x minus cosine of x. Yeah? So that's simply secant x plus tangent x minus sine of x from 0 to pi over 2. And now I see that, okay, plug in 0, I get 0. Plug in pi over 2, this is just minus 1, right? But then I see a problem, pi over 2, that's infinity. And that's where this kicks in. So let x, pi over 2, we have sine of x, ln of cosine of x, plus ln of secant x plus tangent of x. Now this converges. And then this and this. Again, we have pi over 2, sine pi over 2. That's 1. So we have negative 2. Okay? Alright, let's clean this portion up. Okay. Time to compute the limit. Let's unblock the blocking limit. Limit blocking. Okay. So now this is equal to the limit of x approaches to pi over 2. What we have is cosine of x to the power of sine of x plus secant of x tangent of x. Is this a good idea of what I'm doing? Is this even a good idea? Well, secant of x plus tangent of x, what is this? Secant of x plus tangent of x, this is actually cosine x of 1 plus sine of x, right? Okay, let's put a minus 2 there. So what now? What do we do here? So we're gonna put the limit inside the ln, technically speaking. We can call this green. Okay. We have cosine of x, sine of x minus 1 plus sine of x. 1 plus sine of sine pi over 2. Oh, this is 2. Okay. So that means that something must converge here. Cosine of x, sine of x minus 1. This is literally pi over 2, 0, 1 minus 1, 0. I see what's going on. So now, I was gonna be like, I think this is allowed, but because this is technically 0 and 0, you're literally solving this portion, right? Be very careful. Be very careful. Sometimes you cannot do that. That would be mathematically disrespectful to your calculus teacher. But for those who don't know how to handle something like this, what you do is you let e to the ln of this whole thing. It's the loophole log that we learned in our intermediate training, right? We get sine x minus 1, and then plug in pi over 2, we get ln of 0, but then we get this. This is literally, this portion here is the exact same scenario of dealing with this for the limit as x approaches to 0. That's literally what we're doing. And we know that this is equal to 0, right? And so because of that, we know that computing the limit of this on top, it's going to equal to 0. So what this is going to give us is this is going to give us 2e to the power of 0, which equals to 2. Now be mindful that what we have here is this is ln of 2. Do not forget that. So our whole answer, and remember we have minus 2 here. So our answer for that whole nasty ass integral is ln of 2 minus 2. the majority of that integral has nothing to do with ninja substitution. It was a lot of integration by parts and limit blocking. So, but yeah, this is the answer. So that was our last integral. Again, just because ninja substitution looks easy doesn't mean it always is. All right. So, yeah, that's a tough integral. So, good luck solving that one. Good practice, though. Very good practice. All right. Thank you so much for watching. I hope that was helpful. And I'll see you guys in the next section.